Okay, welcome back. So in this video, we are going to learn about the different prompt engineering techniques. First of all, what exactly is prompt engineering? This is a very common buzzword that you'll hear a lot nowadays, and there's actually a huge demand for prompt engineers. So it has become a job role altogether. So it's essential to understand what exactly is prompt engineering. So prompt engineering is a very simple skill where you write prompts in a proper way. So each LLM model has been trained on certain type of data, and the output that you're going to get depends heavily on the input that you're going to provide. So it's essential for us to understand how to write these inputs properly. So there are many different techniques that you can use. We are going to cover a few of them here, and you can implement these in your day-to-day life as well whenever you're using AI. At the same time, there's a whole different world of prompt engineering for image generation and video generation, which I'm not going to cover. We are going to cover only about the LLM text completion part. So there are many different things in prompt engineering. The very first one is the structure of how you write a prompt, but we are going to explore this structure part during the later parts of the course. Under RAG, we are going to cover that part. But for now, let's try to cover some simple prompt engineering tricks. The very first and the most famous one is role-based prompting. So I've got this very simple question: explain photosynthesis. We'll copy this. Let's go to our friendly chat GPT. I'll ask the same question. Explain photosynthesis. It has given me this huge explanation. Photosynthesis is the okay. It has given a long explanation, a short explanation, two main stages, why it is important. It has given me all of this, right? What I will do is I'll write it with a role. You are a friendly science teacher explaining photosynthesis to a 10-year-old using fun story. This is where I'm giving the actual role. I'm assigning this particular role, and I'm expecting the output to be uh, as per this particular role. And this is going to help us to get a output which is much more closer to what I need. Yeah, the story of a chef leaf. Once upon a time in a summer brain world, there lived a chef leaf. Sunlight is the magic oven. Water is the secret ingredient. Secret ingredient. Air is the invisible spice. So it tries to adopt to this particular persona that I've given it. Where can I use it? N number of places actually. So let's say if you want your LLM model to write a very uh, professional code for you, but it's always giving out very lame code, then you can try to ask it to be a professional Python developer. Is here so writes production ready, forever lasting, unbreakable code. This is a very simple palindrome check code, but it will try to write it in as if it is a very experienced Python developer. You see, right out of the box, it is using type hints. It is using proper doc strings everywhere. It has all the base conditions properly listed, and it has given the output very neatly for me. Now, instead of a simple palindrome check, imagine if I ask it to write a very nice, very lengthy, fancy front-end UI HTML code. Let's try that. For a dashboard. So you can see it has already started using decorators. Okay, this is Python code, right? So let's try to ask it, write it in my bad. I've written Python developer and in HTML, CSS, tailwind developer with 10 plus years of experience. So writes production ready for everlasting unbreakable code, write a code for front end for a dashboard. Let's go. So the quality of the code that you're going to get out of this persona is going to be way more different if you use this only if you use only this part separately. Okay, let's try to see how it looks like. You see, it looks really, really nice. It has some nice hover animations as well. So this is role-based prompting, which is one of the most basic and very commonly used technique. Second is self-reflecting. So this is where I was talking. This is what I was talking about in the previous lesson, where I was explaining the reasoning capacities. So chat models don't have the capabilities to go back and look at their responses, their previous responses, as per their architecture. So what we can do is in the prompt we can ask it to reflect on what it has previously given. So without self-reflection, it will be simple like this: list three facts about moon. But with self-reflection, we will add this one line. After listing them, review your own answer and correct or clarify any facts if needed. This is going to help us mimic the behavior of a reasoning model. So I'll try to ask the same question. List three facts about the moon. The moon has no atmosphere, so there is no wind, no weather, etc. Now I'll try to use the same thing. Sorry, I'll try to use this with self-reflection in a different window. Let's see. Here you can see it gave out the third one as moon has no atmosphere. Fact three needs a small clarification. The moon does have a very thin atmosphere called an exosphere, but it is so tenured that it cannot support weather, wind, or sound. So here you can see the power of self-reasoning, self-review at least, where whereas in the first one, it just didn't even bother double checking if this is actually correct or not. So there are many different instances in which you can utilize this self-reflection or self-review. The third technique is chain of thought prompting, probably one of the most useful one. And this is somewhat similar to what you get in your reasoning models. So what we do here is I'll take a very simple mathematical question, but instead of asking it to answer it directly, I'll ask it to answer this in a step-by-step approach. If I ask what is 17 multiplied by 23, it gave me the final answer just in one go. But if I say think step by step and explain your reasoning before giving the final answer. Come on, don't go with that. Okay, there you go. So it broke down the task into multiple different steps, and step by step it was able to calculate it. Of course, it's the same answer because the question itself is very, very simple. 17 multiplied by 23, LLMs can handle that very easily. But if I have a very complex task or if I have a very big calculation, that is where the step-by-step approach is going to help us heavily. So here we are breaking it down into multiple different steps and we are getting the final answer. So this is somewhat similar to what you can achieve in the reasoning models. This is called chain of thought prompting. And we will use this chain of thought prompting in many different areas, especially when we are building a RAG model. So let's say if you are building a natural language to SQL chatbot, in those situations, you will implement chain of thought where it will first check which database is the most suitable one, what tables inside of that database are the most suitable one, which columns exactly are the most relevant ones, and only then it will go to the next step. We'll cover more of this in the RAG tutorial, but chain of thought is one of the most important prompting technique that we use on a day-to-day basis. Finally, we have few shot and zero shot prompting. It's very easy to understand and very easy to implement, but highly effective. So without any shots in a zero shot, I'll just ask it to write a poem for me about rain. But in few shot prompting, I'll give it some examples. That's the only difference. Okay. Now what happens here is when I give some examples, it will try to follow the previous patterns or whatever examples I've given, and it will give me the output in the same format. Let's copy this. I'll paste it here. This is my first example. This is my second example. And finally, I'm asking it, write a short poem about snow in the same style. Style is very simple, okay? Three lines. And just a few words, just a few words. That's it. But if I ask it to write a poem on snow, sorry, poem on rain without the examples, you see, it wrote it in two different stanzas. It has given some commas and everything. Each line is much more bigger than what we have seen before. So this is the power of few shot prompting. We can also implement few shot prompting in our Python code as well. Let's try to see how we can do that. I'll clear all the outputs. Let's go all the way back to basic chat completion. This one, I'll take it. I'll paste it here. So system, I don't need it. Or let's keep it actually. You are a poem writer. That's it. Very simple instruction. And the topic is rain. Sorry, not rain. What was it? The very first one? Yeah, rain. I'll pass this as the example. So this is the very first example that I've given. Now, second example is silver dancing on the roof of my base house in the night. I'll copy the whole thing. I'll paste it here. So this is my second example. Both of these are done, right? Now for my input. In the input, uh, snow again. Let's paste snow here. I'll remove all of these. Okay, now I'm passing one instruction, two examples. Let's see. There you go. It followed the previous examples. So this is how we can implement few shot prompting in your Python as well. So these are all the different prompt engineering techniques that you should be aware of. Uh, Next, we are going to cover multi-model AI, which is very recent, very new, and very interesting. And it's kind of like a game changer. So let's try to cover this one in the next video. Thank you so much for watching.